Hello everyone, today we are discussing section 8.1 and we are going to talk about what we call the inverse sine, the inverse cosine, and the inverse tangent functions. We have several objectives in this section. We're going to start with finding the values of inverse sine functions, and then after we find the exact values, we're going to look at finding approximate values using a calculator. And we're going to, after that, look at what we call composite functions. So we're going to find the values of some composite functions. And all of this is for the sine function. After that, we're going to look at the inverse cosine function and the inverse tangent function at the end. So before we get into these inverse trigonometric functions, we're going to take a look at a general review of what is an inverse function. This is something that we've learned in previous courses, but we're going to review it because it's very important. So what is an inverse function? Every operation in mathematics has its reverse operation. So the reversal of addition is subtraction. The reversal of multiplication is division. So a function is a mechanism that takes some values and as an input and brings us some other values as its output. So an inverse function reverses this operation of a function. So it reverses the action done by the original function. Let's see what that means. So let's take a function f of x equals 5 times x. What does that function do? Well, it takes any value for x, that's the input, and it multiplies it by 5. So for example, if I input 2 here in that function, then f of 2 is going to be 5 times that number. 5 times 2 is 10. All right, so this function takes any input value for x and multiplies it by 5. So what do you think an inverse function of that one would do? Well, logically, here is the inverse function of f, and it's x divided by 5. So instead of taking a value and multiplying it by 5, it's going to take that value and divide it by 5. So now, if it reverses this operation, so in the first function, when 2 was the input, 10 was the output. In the reverse function, it's the other way around. If I put 10 back into this function, then the answer would be what? 10 divided by 2, it's going to give me back 10 divided by 5, excuse me, it's going to give me back the original value of 2. So that's what we mean by the inverse function reverses the operation of the original function. Please recall that this right here is a symbol, and it's read f inverse of x. That's how we read it, okay? If this is a function f of x, its inverse function looks like this, and it's read f inverse of x. So now let's take this concept and apply it to trigonometric functions. So let's start with the sine function, for example. So sine of x equals some value. So what is the input of the sine function? What do we usually have here? And what is the output? I want you guys to pause the video and think about this for a little bit. What kind of numbers do we usually put here as the input of the sine function, and what numbers are the output of the sine function? Pause the video and think about this for a minute. Well, hopefully you guys were able to recognize that the input of the sine function is usually an angle, right? So sine of 30 degrees, for example, or, you know, it could be an angle in degrees or in radians. So sine of 30 degrees or pi over 6 or 180 degrees or, 3 pi over 2. So the input is an angle, so sine function takes any value in parentheses any angle. Okay, so that's the input. And then what do we get? So sine of 30 degrees is what? Is 1/2, right? What is the sine of 180 degrees? 0. What is sine of 3 pi over 2? -1. And so on. So what values does the sine function give? Numbers, right? But do you guys remember specifically what those numbers are between? They're not just any numbers. They were specifically, as we talked about, they are specifically numbers between, what is the lowest value? They're between -1 and the highest value that we get is +1. So they're all numbers between -1 and +1 and all the decimals in the middle of those. Okay, so the input of the sine function is an angle, and then it gives us a number between -1 and +1. So that's the output of the sine function. So now let's think about something that is going to reverse that. Instead of getting an angle and getting out a number between -1 and +1, the inverse sine function is going to reverse that. So it's going to take this value, it's going to take a value between -1 and +1, and then it's going to give us back an angle. That's what the inverse sine function will do. Let's take a look at what the inverse sine function looks like first. This is what it looks like. And it is read the inverse sine of x. The inverse sine of x. That's how we write the inverse sine function. Please be aware that this -1 right here, that's not an exponent. Okay, it's not sine to the power of -1. That's not a power. It's not a negative exponent, which means this is not a reciprocal. So the inverse sine of x is not 1/, sine of x. Okay, that is not what that is. This is a particular inverse function symbol. Okay, so let's take an example based on what we have just learned. So if sine of 30 degrees is equal to 1/2, then what is the inverse sine of 1/2? Think about it, guys. The inverse sine of 1/2 is 30 degrees, or pi over 6. So that is how the inverse operation for sine is going to work. It's going to take a number from here between -1 and +1, and then it's going to give us back the angle in degrees or in radians, depending on what the question asks you to do. Here's another example. Think about this. Do this on your own. What is the inverse sine of √2/2? Hope that you guys got this. The inverse sine of √2/2 is 45 degrees, or pi over 4. I hope that the idea is clear now for the inverse sine function. What does it do and how it works? We're going to see some more properties of the inverse sine now, and we're going to see examples afterwards. So now we're going to talk about graphically what the function looks like and what the inverse function looks like. So as we just mentioned, the input of the sine function is the output of the inverse function and vice versa. So what does that look like graphically? So if we're graphing a function and its inverse, this translates to the domain of the original function is the range of the inverse function and vice versa. Okay? The range of the original function becomes the domain of the inverse function. So graphically, the relationship between a function and its inverse is translated into domain and range. Let's see what that is graphed like. Here we go. So if you look at the graph of a function, for example, this function here, f of x, and you can see what this graph looks like. Okay, this curve right there is f of x. So if I were to have this function and I would ask you, graph the inverse function, or what is f inverse of x looks like, right here, how would we graph that? This is something that we've seen previously. We're just reviewing it again. So the graph of the inverse function is symmetrical, or it's a reflection with respect to the line y is equal to x, or the 45-degree line right here. So if you want to graph the inverse of this function f, first you would draw this 45-degree line, y equals x, and then you would take every point, for example this point right here, and then you would reflect it with respect to that line, and you'd get a new point on the other side. This point, reflect it right here, this point, reflect it here, and so on. You're going to do that for every point until you reach this graph right there. That's what the inverse function of f is going to look like. Okay, so in essence, this line right here is a mirror. Okay, so this is what the symmetry of any function and its inverse function looks like graphically. It's a mirror reflection about the line y equals x. Now, there are some rules that pertain to inverse functions. Not every function actually has an inverse function. So a function, there are some rules of how do we know whether a function does have an inverse or not. So a function f of x has an inverse function f inverse of x only if this condition applies. Only if a function is something called one-to-one function. Okay, so only one-to-one functions actually have an inverse. If a function is not a one-to-one function, then it doesn't even have an inverse function to begin with. Okay, how do we know whether a function is one-to-one or not? Graphically, this is a very neat thing. We can tell using something called a horizontal line test. Okay, a horizontal line test. The horizontal line test says if any horizontal line intersects the graph in more than one point, then the function is not one-to-one. Okay, so a function is one-to-one only if every horizontal line intersects the function at most one point. So let's take a look at these examples here. So the quadratic function, the parabola, y equals x squared, very famous one. Is that a one-to-one function? Well, if I draw any horizontal line, it is obvious that it intersects at more than one point. Okay, everywhere, except right here at the vertex, it intersects at only one point, but doesn't matter because horizontal lines, some horizontal lines intersect at more than one point, then this is not a one-to-one function, okay? This quadratic function does not have an inverse function. Now, someone has been paying attention and would say, hey, wait a minute, how come this function doesn't have an inverse? Couldn't I reverse that and say y equals the square root of x? Isn't that an inverse function of y equals x squared? Well, yes and no. Yes and no. It only works for positive values of x, okay? Because if I put a negative value here, I get an imaginary number, right? But I can put a negative value here and square it, that's no problem. So actually, the parabola, or y equals x squared, only has an inverse for positive values, only for that side of the function, okay? Not for the other one. So only for this part, only for this positive part of the function, it would actually have an inverse, all right? So we're going to see that later, but maybe if we restrict the quadratic function, if we pretend that this part is in there, then it would actually be a one-to-one. It would intersect at only one point, and then we can have an inverse function. Recall that y equals absolute value of x is a function that looks like this, right? So that would actually be a inverse function for just this part of x squared. This is a neat trick. We're going to explore that a little bit more. But for now, we're just talking about the horizontal line test. How do I know if a function is one-to-one? How about this one, the cubic function, y equals x cubed? Yes, absolutely, it looks like a one-to-one function. It intersects at most one point, so we're good there. This is a one-to-one function. Can you tell what the inverse function is? I hope you guys can. What reverses the operation of cubing a value? The cube root. The cube root of x. And if you are curious, or based on you knowing what this what the family of functions look like, we know that the x cubed function looks like this. So that is, again, a reflection about the y equals x line, the 45-degree line right here. And this is y equals the cube root of x. Now, why is it that x cubed has an inverse, but x squared does not have an inverse? Well, there's no such restriction about the negative values in cube, right? The cube root of x, this can be negative or positive values. What is the cube root of -8? -2. So the cube root and the cubic function don't have a restriction like the square root and the cube and the quadratic function does. Okay, I can input here negative values. I can have -2. What's -2 cubed? -2 cubed is -8. And I can reverse that back. I can put the cube root of -8 and it gives me back the same value, -2. Whereas in the square function, if I put -2 here, -2 squared gives me +4. But if I put the square root of +4, I do not get -2 back. The square root of +4 is +2. Okay, so I hope that this distinction is clear, but what's important for you guys to remember now is the horizontal line test. Okay, how do I know that a function has an inverse if it passes the horizontal line test. So now let's take a look at the sine function. And here's a graph of the sine function. And the first thing that we should notice is that a one-to-one function? And the answer is no. It fails the horizontal line test. Look, if I draw any horizontal line, it's going to intersect the function at an infinite number of points. It's a periodic function, so it keeps repeating itself. It's going to be very, it's definitely not a one-to-one function, which means that the sine function, the way it is, does not have an inverse function. So what can we do? Similar to what we spoke about before, with the quadratic function, one of the tricks that we can do is we can restrict the domain of the function. So we can cut it off so that it would be a one-to-one function. And if you look at the sine function, because it's a periodic function, it repeats itself from this point to this point, the negative pi over 2 to positive pi over 2. And if I, let's say, magically erase this part here and this part here, this is what we mean by restricting the domain. If we just look at this and magnify that, like so, then it is a one-to-one function. So now any horizontal line is going to cross the function at only one point, okay? And this here enables us, so this restricting of the domain of the sine function enables us to find an inverse function that is defined for the sine function, okay? So this is the trick, but now things are going to be different, because before the input of the sine function, any angle, okay, any negative angle, any positive angle, okay, any angle was the input of the sine function, okay. Now the input of the restricted sine function is not going to be any angle. It's going to be angles only between negative pi over 2 and positive pi over 2. Okay, so only angles that are between negative 90 degrees and positive 90 degrees. Why does that matter? Well, remember that the inverse function gives us back an angle. Okay, the sine function takes an angle and gives us a value between negative 1 and positive 1. The inverse sine, so this is for the sine, the inverse sine is going to do the opposite. It's going to take a value between negative 1 and positive 1, and then the output is going to be an angle, but it has to only be an angle between negative pi over 2 and positive pi over 2. And that is going to be crucial for calculating the inverse sine. So here's a reiteration. If we restrict the domain or the inputs of the sine function only to negative pi over 2 and positive pi over 2, then the function becomes one-to-one, and then it has an inverse function. Okay, so what do we need to understand? Concept. The inverse sine, so let's just write it. So the inverse sine function is only defined for angles between negative pi over 2 and positive pi over 2. okay? The inverse sine is only defined for angles between negative pi over 2 and positive pi over 2. That's an important concept. Okay, here's a reiteration of what we just talked about. It is just written in a more complicated way, but if you understood what I was just saying, then you understand what that is. And this here, curiously, if you want to know what the inverse sine function looks like, so here is y equals sine of x. This is the restricted sine function. We cut it off here at negative pi over 2, and then it just went to positive pi over 2. And then if we want to graph the inverse sine function, we can graph the line of symmetry, y equals x, and then this here is what the inverse sine function looks like. I'm not going to ask you to graph it, the inverse sine function, but you should know what it looks like. You should also know the domain and range for them. So what would the domain of the inverse sine function? So the domain is going to be a value from -1 to +1. That is the input. And the range, that's the important one. It's going to be negative pi over 2 to positive pi over 2. Okay. Here's the concept again. Please make sure that you write it down and know it and understand it. The inverse sine function takes any value or input between -1 and +1 and then gives an angle only between negative pi over 2 to positive pi over 2. This is the important part. Okay, the inverse sine function gives an angle that has to be only between negative pi over 2 to positive pi over 2. That's the only range where it's defined. Now, where are these angles? So if I have my coordinates right here, where is negative pi over 2? Right there. This is negative pi over 2. And where's positive pi over 2? Right there. So this is the only area where the inverse function is defined. So that is quadrant 1 and quadrant 4 only. Okay, so the inverse sine function is only defined in Q1 and in Q4. That's an important concept. Okay, another name of the inverse sine function, you might have heard it before or you may have seen it on some calculators, is arcsine. So when we say the inverse sine of x, you can also refer to it as the arcsine of x. It means exactly the same thing. Inverse sine and arcsine are synonymous. And lastly, we have mentioned this before, the inverse function is not reciprocal, meaning inverse sine of x is not the same thing as 1 over sine of x. That's something that we've mentioned before. So now that we've learned all of these things about the inverse sine function, let's actually start with our first objective. Find the exact value of an inverse sine function. And here's an example. What is the inverse sine of square root 3 over 2? Remember, the inverse sine takes a value from -1 to +1 and gives an angle. So this has to be an angle between what? Negative pi over 2 to positive pi over 2. Okay, and it says find the exact value in radians. So what angle in radians is the angle that has sine square root 3 over 2? Now, it's probably super helpful at this point, even though you may recognize a lot of values now for sine and cosine. I hope that with all the practice from previous modules and sections that those values are now ingrained in our heads, but if not, let's just review real quick. There are 3 angles that we must know. Pi over 6 or 30 degrees, and the sine is going to be the opposite over the hypotenuse. So sine of pi over 6 is 1/2. There is 45 degrees or pi over 4. Sine of pi over 4 is 1 over square root 2, or in other words, it's square root 2 over 2. And the third one is pi over 3, or 60 degrees, and that is sine of pi over 3 is square root 3 over 2. Okay, so which one would this one be? What is the inverse sine of root 3 over 2? That's this one right here. The answer is pi over 3. Okay, and that's simply how this works. What about this one? What is the inverse sine of 0? Well, let's recall that with those values we can use the unit circle for those quadrantal angles. Remember, this is the point 1, 0. This is the point 0, 1. This is the point -1, 0. This is the point 0, -1. Recall that the sine are these values here, or the y values. So this is sine, 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 and sine. So this question is asking which angle has sine equal to 0? Which angle has sine equal to 0? Look at this. Well, obviously, angle 0 degrees, right? Sine of 0 degrees is 0, but pi, also, sine of pi is also 0. Not only that, but 2 pi. That's the same angle as 0, right? Sine of 2 pi is 0. And sine of 3 pi. And so on. I can even go in the negative direction, right? I can say that negative pi is also 0. So where is the answer? Where is the answer? Is it 0 or pi or 2 pi or 3 pi or negative pi or all of them? We have to go back to the concept, and this is again why that concept was very important, because the inverse sine, guys, the inverse sine is only defined where? It's only defined in a specific area, not everywhere. It's only defined for an angle between negative pi over 2 and positive pi over 2, only in this area right here, only in Q1 and Q4. Okay, only between negative pi over 2 and positive pi over 2. So none of those angles are an answer, okay? Even though that sine of pi is 0, but the inverse sine of 0 is not going to be pi. It's only going to be this angle here, and not 2 pi, because that's greater than pi over 2, okay? So that's outside of our range as well. So the only answer is inverse sine of 0 is 0, okay? I hope that those two examples are a clear demonstration of what we're doing here and how we can find the inverse sine functions. Let's do a couple more examples. Our next example asks, what is the inverse sine of negative square root 3 over 2? So now we have a negative quantity. Okay, so let's again draw our coordinate system. And again, recall, where is the inverse sine defined? It's only defined here, between negative pi over 2 and positive pi over 2. Okay? Only those angles between those two values are where the inverse sine function defined. So now, which one of these angles has the sign negative square root 3 over 2? Well, first of, which quadrant is this going to be in, you guys? The inverse sine is only defined in two quadrants, quadrant 1 and quadrant 4. Now, which one of these quadrants will the sign be negative? Well, we know that everything is positive here in quadrant 1, so sine is positive in quadrant 1. What about quadrant 4? Well, sine is negative in quadrant 4. Remember, all students take calculus, so only cosine is positive in quadrant 4. That means the sign is negative. Okay, and that's very important. So whenever we see, this is a concept, so whenever we see a negative value here, that means we're looking for an angle in Q4. This negative indicates, you can write this down, that we are looking for an angle in Q4. Okay, because that's where the sign is negative. In Q4. Okay, so which angle is that, you guys? So which angle has the value square root 3 over 2? Well, I think that's the same one that we just talked about, pi over 3, correct? Pi over 3, 60 degrees. So we are looking for pi over 3 in Q4, which would be this angle right here, negative pi over 3. Okay, negative pi over 3, that is the answer. That's the angle between negative pi over 2 and positive pi over 2 that has the sign negative square root 3 over 2. So the answer here is negative pi over 3. Now, please be aware that you may also say, hey, isn't that the same angle as 5 pi over 3? So couldn't I just say that the inverse sine of negative square root 3 over 2 is 5 pi over 3, or do I have to say negative pi over 3? It's the same angle. What do you guys think? Well, true, it is the same angle, but we have to keep going back to our concept. Where is the inverse sine defined? The inverse sine is only defined between negative pi over 2 and positive pi over 2. Okay? Pi over 2 is the largest value. 5 pi over 3 is clearly bigger than that. That is outside of where the inverse sine is defined. Okay, so once again, concept, I'm writing it again. You probably wrote it before, but it doesn't hurt. This is an angle only between negative pi over 2 and positive pi over 2. Okay. All right, I'm going to let you guys pause the video and do this one on your own. Please pause the video, do this one on your own. Find what is the inverse sign of negative square root 2 over 2. Play the video when you're done. Okay, once again, we're looking for an angle here. Okay, in Q1 and Q4. This negative tells us that that's going to be an angle in Q4. Which one? So square root 2 over 2. What angle has sine square root 2 over 2? 45 degrees, or pi over 4. So that means our angle is this one right here, which is negative pi over 4. So the inverse sign of negative square root 2 over 2 is negative pi over 4, and that is our answer. Okay, now we have been identifying exact values of the inverse sine function. Our next objective is find approximate values of inverse sine function. So sometimes we don't have exact values. We only know the exact values of angles that are going to coincide with 30 degrees, 45 degrees, and 60 degrees, and then the quadrantal angles, negative pi over 2 and 0 and pi over 2, but there's so many more angles than those, obviously. So if it's not one of those exact values, we can find an approximate value using our calculators. So if you do not have your calculator right now, please pause the video and bring it out, and we're going to go over how to find inverse function values for approximate values for those. So we have a couple of examples. Find the value of the following expressions in radians. This is very important. So the first thing you want to do is you want to make sure that your calculator says radians. Okay. And then it says round to 2 decimal places if needed. So we are going to round if we have to. And the first one says, what is the inverse sign of 0.3? Now it is obvious that 0.3 is not one of those values that we know. Okay, it's not 1/2, it's not square root 3 over 2, and it's not square root 2 over 2, and it's not 0, or the negatives. So we will have to use our calculators for that. So just to show you, or to tell you how to do it, on the TI-30X2S, the button that says sign, right above it says the inverse sign. So what you need to do to get there is you press on the second button. So you're going to press second and then sign, and then you're going to put this value 0.3. Again, make sure that your calculator says radians, and then press enter, and that should give you the value of 0.3. So it's actually the angle 0.3 in radians. Remember that the values in radians, the values of angles in radians, guys, is going to be an angle, or it's going to be a value between negative pi over 2 and positive pi over 2. So recall that pi is approximately a value 3.14 if I round to 2 decimal places. So pi over 2 is approximately 1.57. Okay, so this is going to be somewhere between 1.57 and negative 1.57 and positive 1.57. That's what negative pi over 2 and positive pi over 2 are. So if I'm getting an angle in radians, it's going to be in this range. Okay, because it's going to be approximate and not exact. So it's not going to have pi over something. It's going to be an decimal approximation. Okay, what about this next one? What would be the inverse sign of negative 0.59. Also, go ahead and put this in your calculator. And the answer is approximately, if you round it to 2 decimal places, would be negative 0.63. So again, keep in mind that this is what we're working with, an angle between negative 1.57 and positive 1.57 approximately. Our next objective is to use what we've learned about inverse functions and find the value of something called composite function. And a composite function is a function within a function, and we've seen that before in some algebra courses, something like g of f of x. So that is a function, f of x, within a larger function, g of x, for example. So it's two functions within each other. That's the general definition of a composite function. So now we can do the same thing with this, the trigonometric functions. So something like that. There's an inside function, which is sine of pi over 4. And then there is the outside function, which is the inverse sine of that value. Okay, so it is a function within a function. And we read that as the inverse sine of pi over 4. The inverse sine of pi over 4, or the arcsine. Remember, inverse sine, another word for it is arcsine. The arcsine of pi over 4. So how do we do this? Two simple steps. Our first step is to evaluate the inside function. Okay, so first we take the inside function, this sine of pi over 4, and we get the value for the inside function. And then step number 2, we will evaluate the outside function. So 2 steps. So for example, in this example that we have, our first step is to evaluate sine of pi over 4. What is sine of 45 degrees? Square root 2 over 2. So we take square root 2 over 2 and replace sine of pi over 4 with it. And now it becomes the inverse sine of square root 2 over 2. And that's an easy one because we've done that before. What is the inverse sine of square root 2 over 2? It's the angle pi over 4. And these are the steps for evaluating any composite function. Do the inside function first and then the outside function later. Now, you can probably recognize that, hey, this is curious. What happened is this here gave us pi over 4, which is exactly the same angle here. So the inverse sine of an angle gave us back the angle, which kind of made sense, because if I have a function like sine of an angle and then I reverse it, because the inverse sine reverses the operation of the sine function, then I would get back the original input that I had. Now, does it work like that every time? No. And we're going to see examples of how this is not going to be the case. And the main reason why it doesn't work like this every time is because the inverse sine is not a perfect reversal for the sine function. Remember that we were only able to find an inverse function when we restricted the domain of the sine function. Okay, so only for angles between negative pi over 2 and positive pi over 2 that this would work that way. But for any other angle that is not restricted, it's going to be a different story. And don't worry, we'll see plenty of examples that will explain what we're doing here. Let's go ahead and take those examples together. Find the inverse sine of pi over 6. Okay, composite function. Let's review the concept first. We're going to evaluate the inside function. So what is sine of pi over 6? Sine of 30 degrees is 1/2. So we're going to rewrite this as the inverse sine of 1/2 Okay, and then step number 2, evaluate the outside function, which is this. What is the inverse sine of 1/2? Again, remember that the inverse sine is an angle between negative pi over 2 and positive pi over 2. This is a positive value, so we're looking in quadrant 1. That's going to be an angle in quadrant 1 because the sine is positive. And which angle is that? What angle gives us the sine of 1/2? It is pi over 6. So the answer here is pi over 6. So this is another example where we got back the same input that we've had before. But let's move on to the next example so you'll see why this is not always going to be the case. So this says the inverse sine of 5 pi over 6. So let's check this out. That's our first step. What is sine of 5 pi over 6? Well, where is 5 pi over 6? Let's draw that angle. 0, pi over 2, pi. So if we're talking about a fraction of 6, pi, we can think about it as 6 pi over 6. So where is 5 pi over 6 going to be? It's going to be 1 pi over 6 short of that. So it's going to be somewhere right here, where this is 5 pi over 6. And the reference angle for that is what? Pi over 6. Okay, so what is sine of this angle? Well, we can go ahead and draw our right triangle. This is a pi over 6. So the ratios are 1, square root 3, and 2. But be careful here, because this is in the negative direction. This is in the positive direction. The hypotenuse is always positive. So sine of 5 pi over 6 is going to be positive 1 over positive 2, which is 1/2. So now we get the inverse sine of 1/2. The inverse sine of 1/2. That's what sine of pi over 6 is, 1/2. Okay, and now we evaluate this. That's step number 2. What is the inverse sine of 1/2? Well, we actually just did that. It's the same as what we did in the first example. It's an angle in quadrant 1, the angle whose sine is 1/2, and that's the angle pi over 6. So the inverse sine of 1/2 is also pi over 6. So notice the first example and the second example, even though the inside function was different, we ended up with exactly the same value. So that right there is an example of why you do not always get that input that you started with. Let's do 2 more examples, guys. Those are going to be yours to do. What is the inverse sine of 7 pi over 6? So I want you guys to try this on your own. So get out your notebooks and do the steps. Our first step is, what is sine of 7 pi over 6? And obviously, in order for you to figure that out, I want you to start by drawing the angle 7 pi over 6. So figure out what that angle is. And then whatever that value is, sine of 7 pi over 6, you're going to write it here. And then your step number 2 is going to be evaluate the inverse sine of that value that you get. So please pause the video, do this on your own, and then play the video again when you're finished doing so. Okay, once again, where is 7 pi over 6? Well, 6 pi over 6 is pi, which is right here. So 7 pi over 6 is going to be one more there. So this here is the angle 7 pi over 6. What is the reference angle for that? The reference angle is pi over 6. Okay, what is sine of that angle? Let's draw our triangle. The ratios again, 1 square root 2, excuse me, square root 3, and 2. I hope that I did not make that mistake in the previous one as well. I didn't put square root 2, did I? You can rewind the video, and if this is something that I made a mistake on and you are confused, I apologize about that. That's a typo. So the ratio is 1 and square root 3 and 2. So this is in the negative direction, and this one is also in the negative direction. The hypotenuse is positive. So what is the sine of 7 pi over 6? It's going to be negative 1 over positive 2, or negative 1/2. Negative 1/2. So now step 2 is figure out where or what is the inverse sine of negative 1/2. Well, once again, the inverse sine gives us an angle between negative pi over 2 and positive pi over 2. The fact that this is negative tells us that we're going to be looking for an angle here in Q4. And which angle is that going to be? The angle whose sine is 1/2, that is pi over 6. So pi over 6 here in Q4, it's going to be negative pi over 6. So our answer is negative pi over 6, because it's an angle in Q4, and that is because the sine is negative. Okay, I hope that everybody got that. If not, please, I hope that you now know where your mistake was, if you made a mistake. It's good if you make mistakes now, because now gives you a better understanding. So every time we do this, every time I ask you to do an example on your own, please actually do so, just so you know where your potential mistakes are going to be. Okay, try the next one, guys. What is the inverse sine of 3 pi over 4? Once again, start here. And when you do that, when you're done with that, do the second step. So pause the video, try this next example, and then play the video when you have finished doing so. Okay, let's start with sine of 3 pi over 4. Where is 3 pi over 4? That is an angle right here. The reference angle for which is pi over 4, right there. To find the sine of that angle, the ratios are 1 square root 2. This is in the negative direction, this is in the positive direction, this is positive as well. So sine is going to be positive 1 over square root 2, or square root 2 over 2. So we have the inverse sine of square root 2 over 2. And now step 2, we're going to look at this value. So now we're looking for an angle between negative pi over 2 and positive pi over 2. Which quadrant will we be looking at? This here is positive, so we're looking at an angle in the first quadrant, and it's the angle whose sine is square root 2 over 2, meaning it's the angle pi over 4. So the answer here is positive pi over 4. Okay, more composite functions. Different format this time. So instead of the inverse sine of sine, this one is going to be in the form of sine of the inverse sine. The concept doesn't change. We still have an inside function, so we're going to evaluate the inside function first, and then we're evaluating the outside function. So we're doing exactly the same thing, the same steps, same concept, with just a different order this time. So let's try this, guys. Our first example says, what is the sine of the inverse sine of 1/2? Okay, so your first step now is to evaluate the inverse sine of 1/2. You're going to do that first. And then, when you're done doing so, you're going to evaluate sine of that quantity. So please pause the video and again do that on your own. First, find out what is the inverse sine of 1/2, and then find the sine of that number. Pause the video and play it when you're done. All right. Step 1. What is the inverse sine of 1/2? Again, we're looking for an angle. Which quadrant is that angle going to be in? The sine is positive, so Q1. Which angle has sine equaling to 1/2? Pi over 6. Okay, so now we have sine of pi over 6. It's an easy one. What's sine of pi over 6? 1/2. Very good. I hope that you guys got that one easily. Let's try the next one. Do the same thing, please. Pause the video. Evaluate this one. Now be very careful in evaluating that. And when you have finished, then do the next step. So pause the video, play when you have finished. Okay, let's evaluate the inverse sine of negative square root 2 over 2. Which quadrant are we looking for that angle in? The sine is negative, so we're looking in Q4. And what angle has a sine of root 2 over 2? 45 degrees, pi over 4. So that would be the angle negative pi over 4 right there. So this expression is the equivalent of sine of negative pi over 4 which is what? Sine of negative pi over 4. So again, if that's the angle and I'm trying to find sine of that angle, the ratios are 1, 1, and square root 2. This is in the negative direction, positive and positive. So that's going to be negative 1 over square root 2, or negative square root 2 over 2. So it works both ways with composite functions. You can have the inverse sine of sine, and you can have the sine of the inverse sine. Now let's also find some approximate values, some exact values, but using the calculator. So the first composite function is what is the sine of the inverse sine of negative 0.3. So let's get out our calculators, pause the video if you don't have them, and let's evaluate the inside function. So we're going to use the inverse sine, which we do know it's going to be second and sine. So on the TI-30X2S, that's what we're going to type, second and then sine. And that's going to be the inverse sine, and then we're going to put the value of negative 0.3. Make sure that you know that the negative is not the minus on that calculator. All right, so when you want to put a negative number, it is all the way on the bottom. It's the button that has the negative sign in parentheses like that. So you're going to do second and then sine, which is going to type inverse sine above, and then negative, and then the negative button, and then you're going to do 0.3. And you're going to click enter. When you do that, this is going to give you a value approximately negative 17.45760 and so on. Now what you do not want to do is you don't want to round this up. You don't want to say, for example, that's going to be approximately negative 17.5, and then next you do sine and negative 17.5. That's going to be a huge mistake. Okay, you do not ever round until your very final answer. So basically, the next step is you want to type in sine, okay, but you want to use this whole number. How do you do that? Well, you don't want to write the whole number down and then, have to use the whole thing without ever rounding, because even if you do that, you're still rounding because the calculator doesn't give you the whole irrational number. So the best way to do this is through the button that says answer, or ANS, and that's actually the button that is right above the negative sign. So right above it, it says ANS, and that uses the whole previous answer. So what you want to do is you want to leave this on the screen the way it is, and then click on the sine button, and then second, and then this button, okay, which is going to be the ANS. Okay, so sine of the answer, click enter, and that should give you negative 0.3, which makes sense. You get the same answer again in this case. Okay, what about this next one, you guys? Go ahead and try this on the calculator. If you get something weird, it's not a mistake, but I want you to think of why that is. So pause the video and give yourself a minute or so to think about this question here and why you're getting the answer that you are getting. Okay, so what happens if we do the inverse sine of 1.2? Most calculators are going to give you an error of some kind. Now, why is that, you guys? Why is that? Well, let's think about it. The inverse sine, if you recall, that gives us an angle, right? We're supposed to be finding an angle. What are the properties of this angle? We're supposed to find an angle whose sine is this value. Okay, we're supposed to find an angle where the sine of that angle is 1.2. Do you see anything wrong with that picture? Sine of some angle is equal to 1.2. Is there something wrong with this? Yes, absolutely. What do we know about the sine of any angle? We know that the sine of any angle is a number that has to be between -1 and +1. The smallest sine of any angle is -1, and the largest sine of any angle is +1. It's the same thing with cosine. So there is no angle whose sine is 1.2. Okay, so what is the sine of the inverse sine of 1.2? That is undefined. Okay, this answer is undefined. Hope this makes sense. Let's meet again in part 2 of section 8.1.